Hello, hope you're doing well. In this lecture, we are going to discuss about chemical reactions and equations. We have discussed about chemical formulas, elements, atomic number, all that basics in the previous lectures. Now we are going to learn about how to make a chemical reactions, how to write it, how we can write the products, everything. Just remember one thing, when it comes to chemical reactions, we can't just make any reaction in our head and write it down over here on the paper or on the tab anywhere. It has to be experimentally proven. Only then we can write that equation. If it's experimentally proven, it can be published in the books. Otherwise, it cannot. So we need to remember it, something cooked up in our mind, some imagination. We can't write it on a paper if it is not having any experimental evidence in the literature. So before starting chemical reaction and equations, the very first topic that we need to remember is a difference between physical and chemical changes. So, physical changes and chemical changes, about this we have discussed. We have not discussed, but you have studied about these changes in your lower grades. So, if we need to differentiate physical and chemical changes, so we can start with this first point. Physical changes are generally reversible. So best example that you can take over here is water, H2O, dihydrogen monoxide. If it's in the ice form, solid form, so if we heat it, it will change into liquid form. So S over here stands for solid state, L over here stands for liquid state. So when we heat ice, it is going to change into liquid. So there is no change in the chemical composition when it comes to physical changes. There is only change in state of matter. So we can write it over here. There is no change in chemical composition because no bonds are going to break down in this process. The chemical formula of water is exactly same. You can see it. There is no change in chemical composition or chemical properties. There can be change in physical state. So we wrote above that solid is changing into liquid, and this is very much reversible. That confirms the first point, that liquid can go back to solid state if we cool it. So the same water, if you put it in the refrigerator, it's definitely in the freezer, it's definitely going to solidify and change itself into ice. So it's very much reversible, and this sign determines the reversible process. This particular sign, if we talk about, this indicates reversible nature of any process. Then we can add one more point under physical changes. No new substances are formed. So if we can add few points later on, we can say after discussion, few things like one similarity we can write. So if we come to the chemical changes, so we write they are generally irreversible. Now when I say generally, I have a habit of writing some exceptions. So physical changes are definitely reversible. I wrote generally. We don't have any much you can say exceptions over here. But chemical changes can be reversible also. They can't be only irreversible. Generally, commonly, if you see chemical reactions, chemical changes are irreversible. Once they have changed themselves into some other product or some other form, they cannot reverse it back. So generally irreversible. So I'm going to write a simple example in the word equation. About equations we'll discuss later on. So if we have a metal, the symbol of magnesium is Mg. I'm not writing the symbolic form of the equation over here because I want to introduce it later on. So when magnesium reacts with oxygen gas, it's going to form magnesium oxide, something you might have learned in your lower grades. Magnesium is available in the lab in the form of white color ribbon. So if you hold it and try to burn it with a Bunsen flame, with the Bunsen burner. So if you try to burn it in the presence of air, we have our oxygen gas. So the compound that is formed over here is magnesium oxide. Now that's a chemical reaction. Why do we call it as a chemical change or chemical reaction? Because magnesium is a metal over here. It has different properties. Oxygen gas is in the gaseous form, it's a colorless gas, it's a supporter of combustion. Now it has different properties. Now, when they chemically react, we initiated that reaction by burning process. So, when they chemically react, they are forming a different kind of product, which is magnesium oxide. This is the white color powder. It's a form of basic oxide. It has basic properties. So it's a white color powder. Now magnesium we took, it was a white color ribbon. Oxygen was colorless gas. Now we have totally new properties in magnesium oxide. That's the beauty of chemical reaction. Once the elements, atoms, molecules, compounds react, they will definitely show different compounds having entirely new properties. They don't have any similarity between these elements, something we call it as a reactants. We'll discuss about that in a minute. Then we can add few points over here. All bonds, chemical bonds, break down to form new bonds. New chemical substances are formed. Chemical as well as physical properties are changed. So over here in the second point of physical change I wrote, there is no change in chemical composition or chemical properties, but there is definitely change in physical properties. So we can add this change in physical properties is definitely there. See, initially in this example, water was in the form of ice, it was in the solid state. Then we converted into liquid by heating, which was reversible, no doubt. Then, so we added all these points. Then we can add this point, which is in sync with the third point. Change in physical state may or may not be there. Now, what do we understand by this? Now, magnesium over here is in the solid form. Oxygen is in the form of gas. Magnesium oxide is again solid. Now, there is change in state of matter over here for sure. So, this one example or this one point can be a similarity between physical and chemical change. Now, in some chemical reactions, by coincidence, the state of matter remains same. Either they are all in the gaseous state, liquid, or it can be solid. So, there are chemical reactions where the change of state of matter is not changing at all. It's exactly same, but we are getting new products, we are getting new compounds after the chemical reaction. So, this can be a similarity according to me, that in physical change, the state of matter is changing. But we have a lot of controversies in this physical change because it's a vast topic. So, we can add few controversial statements over here. What about tearing of paper? Like if we take an example of tearing of paper, which is actually under the physical change. So, tearing of paper, after you tear the paper, do you see change in the paper? No. Now, if you go to the molecular structure of the paper, definitely there might be some, you can say, molecular structures might got broken down in that process, but that is on the chemical level, not on the physical level. So, tearing of paper is a physical change, and there is no change in the state of matter over there. So, these changes, when we try to differentiate, there can be a lot of contradictory statements. We can't add each and every example under physical and chemical changes. I told you so, I told you about the example similarity also. Like physical state is a similarity which we can share between physical and chemical change. So, on the chemical front, we can say physical state of matters are definitely changing when it comes to physical changes. In chemical changes also it's happening, but in some chemical reactions or chemical changes, state of matter might not change, but we might get new products from those reactants. Now, quickly closing up this, because this doesn't have much, you can say, detail oriented, we will start with the next topic, that is a chemical reaction. So, what's a chemical reaction? First, we need to understand. So, we can just simply write that chemical reaction involves rearrangement of atoms. So, if you see in this example, magnesium is a metal, oxygen is a gas in the form of O2 that we breathe. So, it is forming magnesium oxide. It's one entity, it's a compound. So, definitely rearrangement of atoms has been taken place. Or we can define chemical reaction is a process in which one or more substances are formed, or we can use a better word, transformed into new substances. So, we can say during chemical reactions, new substances are formed with new properties. Now, remember one thing, in a chemical reaction, we have something called as reactants. So, this is a hypothetical chemical reaction. A and B are something called as reactants. Reactants are substances which react with each other to form products. So, you will always see products. These are nothing but the chemical substances on the right hand side of this arrow, on the right hand side of this equation. And on the left hand side of this equation, we have our reactants. Reactants react together to form products. So a single arrow indicates irreversible process, a double arrow, if it's a reversible, you can say this kind of arrow, this is indicating reversible. But we are not discussing about reversible processes as of now. So we'll be discussing about irreversible chemical reactions only. Then if we go to the next part, this is what we call a chemical equation. Now we'll come to that part, but before that we need to understand characteristics. of chemical reaction. So, what are the characteristics, what are the traits which are going to help us to designate a particular process as chemical reaction? So, there are multiple traits, multiple ways to find it out whether a chemical reaction is taking place or not. So, the very first that we can add, change in state of matter, that is the state of matter, solid, liquid, gas. S stand for solid, L stand for liquid, G stand for gas, and we have AQ. AQ stands for aqueous. So what is aqueous? Anything, any substance, or any substance dissolved in water. Aqueous is a term where your solvent has to be water. We are not talking about any other solvent. If it's any other solvent apart from water, we use the term non-aqueous. And we are not going to use that non-aqueous term in chemical reactions. For us, water is a major or the universal solvent. Then we have, I'm not writing equations, but all these I'll be putting up after indicating the chemical equations part. In order to understand how to write chemical equation, we need to learn the types, the ways to write chemical equation. Then the second is formation of precipitate. Now what's a precipitate? So precipitate, it's a solid substance formed by mixing two solutions. And do remember, precipitate is very much insoluble. It's not going to dissolve. So if you have a test tube and you're doing a chemical reaction, and at the end of the reaction, if you see something getting deposited at the bottom of the tube, that is something we call it as precipitate, short form PPT. Now let's take an example. If we have a salt, silver nitrate. I'm not writing the symbolic equations as of now. Silver nitrate is a white color salt. It reacts with sodium chloride. Now, we can't imagine two salts reacting with each other on their own until unless there is no change in temperature. So, in this equation, we are writing aqueous solutions. So, what do you need to do? You take a pinch of salt or whatever amount, 2 grams or maybe 1 gram. So that, not pinch is like very less, but yes, you can take 3 grams or according to what is required in the chemical equation. So if we take silver nitrate in the test tube and put some water in it, then in the second test tube, if we take sodium chloride, again put some water in it, we made two different aqueous solutions of these two substances, silver nitrate and sodium chloride. So when they chemically react, they are going to form silver chloride and sodium nitrate. So silver chloride is going to form white color precipitates in the test tube, something like this. Whereas sodium nitrate is very much soluble in water. We won't be able to find sodium nitrate at all because it's soluble in water. You won't be able to see it. But what we are able to see is the precipitate in the test tube, that is white color substance. So if you see salt in water, sodium chloride is salt. So if you dissolve salt in water, it disappears after some time because it solubilizes in water. So you don't see it because of its high solubility. That same happens with sodium nitrate also over here. Then we can take another example. Sodium sulfate plus barium chloride. this will react to give you barium sulfate and sodium chloride. Now barium sulfate is again white color precipitate. Now precipitates formation is very much practical. We do it in the lab. So if we don't have any idea what has happened in the lab and we are just making something in our mind, it's not going to help. So these are all experimental reactions that we are writing it down. Next, we can move to change in color. Now in change in color, we can actually write the same equations, these above two equations, because colorless is changing into white. We do have precipitates which are yellow in color, which can be black in color, that I want to take up all these equations in the types of chemical reactions. So change in color can definitely indicate that chemical reaction has taken place. Now there is one concept that I always link over here is this part, which is actually a part of physical change. We heard about, you might have heard about KMnO4, which is potassium permanganate. These are pink to purple colored crystals. So if you take one or two crystals and put it in water, so the color will change into pink or purple. Now this is a physical change. If you add KMnO4 and H2O, it's a physical change. KMnO4 being colored is going to take up the spaces in water because water is a liquid. So there is no chemical reaction happening, but definitely color change for water is happening if we see from that particular angle. But it's a physical change. So we can say change in color can also take place in the physical on the physical front, and definitely it can happen in different chemical equations on the chemical front also. So if there is a chemical reaction and then there is a color change, that's definitely a characteristic of chemical reaction. But if that, you can say no change in the chemical composition of the components that we added up and still they are changing the color, that's still our physical change. It's not a chemical change. Then we go to the next point. Change in state of matter. This we have discussed, solid, liquid, gas. This point I already wrote. So we will go to the next point. Change in temperature. So when it comes to temperature change, we have two chemical reactions. One is called as exothermic reaction. Exo meaning heat energy is released. And then we have endothermic reactions. So in this, heat energy is absorbed. So formation of precipitate, change in state of matter, change in color, change in temperature. These are all characteristics of chemical reaction that we need to remember. Now, if we go to the next part, different ways of writing a chemical equation. So the very first way is something called as word equation that we just did. But the point is, in word equation, do you see the formulas, the number of atoms? Are we able to balance the chemical equation? No. Then we go to the skeletal equation, something we even call it as symbolic equation. Then we go to the third type, that is balanced chemical equation. Now, when I say skeletal, this is definitely unbalanced chemical equation. Now, there is no question of balancing or equalizing the number of atoms when we are talking about word equation. We can't do that in word equation. But yes, these questions can be asked where word equation is written and you have to write the symbolic equation and you have to balance the chemical reaction also. About balancing, we'll discuss in a minute. So let's take that example, the same magnesium one. Magnesium reacting with oxygen giving us magnesium oxide. Now, if you go back to the basics, magnesium oxide formula, how do we write it? Magnesium valency is 2, oxide is also 2. So this will cancel off and the formula that we will get is MgO. Please do not apply maths over here. Mg plus O2 will give you MgO2. That's a wrong way of interpreting. Magnesium oxide is formed because of the valency concept, that magnesium is divalent, oxygen is also divalent, so their valency cancels off and we get the formula MgO. If magnesium can donate 2 electrons, oxygen can accept 2 electrons. So we need only one atom each of both of these, magnesium and oxygen. That's why the formula is MgO. Now magnesium is in the solid state, oxygen is in the gaseous state, magnesium oxide is in the solid state. So how to represent a chemical equation properly? States of matter should be mentioned, symbols should be mentioned, then we also need to balance this chemical equation. Now if you see over here on the left hand side of the equation, magnesium atoms are only 1, oxygen is 2. If you can see this number. When you are balancing the number of atoms on both sides, when I say the term balancing, meaning magnesium atom is 1, over here it's also 1. Oxygen over here are 2 atoms. How do we know? Because of this subscript. This is oxygen gas. 2 atoms are chemically bonded to form one molecule over here. And we have only one oxygen atom on the right hand side. So what do we do? In this, something we call it as hit and trial method. For balancing chemical equations. So on the right hand side, we have magnesium 1 atom, oxygen is 1. So what we can do? In this hit and trial method, just remember this, we can add a suitable coefficient in front of the molecule compound or atom in order to balance chemical reaction balancing follows law of conservation of mass. So it states total mass of the reactants is equal to the total mass of the products. So mass can neither be created nor it can be destroyed. That's a statement for law of conservation of mass. So what we can't change over here, we cannot change the subscripts of the molecules or compounds. So when I say subscript, so we are talking about this number. We can't change. So what we can do over here, now we have two oxygen atoms. So if I put 2 in front of magnesium oxide, that's basically the number I'm taking from oxygen. Because if I put 2 in front of magnesium oxide, oxygen will be 2 atoms. So after balancing, magnesium is 2 atoms, oxygen is also 2 atoms. Now on the left hand side, we have a unbalanced magnesium. So if we put 2 in front of magnesium, this is solved. This is perfectly balanced. We have magnesium 2 atoms, we have oxygen 2 atoms. So if you check this data, this is exactly same. Magnesium on both sides 2 atoms, oxygen on both sides 2 atoms. That is what we wanted. That's the meaning of balancing the number of atoms on both sides. Now, I'll be writing this equation again because I need to explain you one more concept. So what we can do in this, if we are going to take only one magnesium atom, I'll be discussing about these coefficients also. If I put half in front of this oxygen, just remember there is nothing like half molecule practically existing. It's always going to be a whole number. But on the theoretical grounds, we can take a fraction like this only for the molecules of the same element. Meaning, we can never put a fraction in front of magnesium oxide because that indicates half magnesium atoms and half oxygen atom. So remember, we can use fractional coefficient only in front of molecules of the same element. So oxygen is a molecule of the same element. So what will happen? This 2 and this 2 will get cancelled. Now leftover oxygen that we have is only 1, this one. And on the right hand side also one oxygen atom is there. So it's perfectly balanced. We can do this way also. But only on the theoretical grounds, only on pen and paper. We are not saying that we can do this on the practical grounds. We can't say that. We can't do that. But on pen and paper, why not? We can do it. We do have a lot of questions, a lot of numericals based on this. Then if we talk about the next part, these coefficients can be taken as number of moles. So number of moles is directly proportional to this number. If you remember from the previous lectures, this capital N can indicate any number. It can be number of electrons, it can be number of atoms, it can be molecules, anything. So what we are trying to say over here is, we are trying to say that magnesium is 1 mole or 1 atom, 1 molecule or whatever, 1 mole of magnesium chemically reacts with half mole of oxygen gas to give us 1 mole of magnesium oxide. So if you know the coefficient after balancing the chemical reaction, the same coefficient can be used as a number of moles. This can help us solve many questions. Now if you go back to this one, 2 moles of magnesium reacts with 1 mole of oxygen to give us 2 mole of magnesium oxide. So this is also pretty okay. So half mole is on the theoretical ground, otherwise this is a perfectly balanced equation. Now if we go back to another equation, now I like this example a lot. It actually explains a lot of concepts. Now, if we say this is nitrogen reacting with hydrogen to give us ammonia,